Okay, here we go. There's something strange going on with the DNA results. I don't know. Maybe someone can help me with this because at first it was like a shock to me and I couldn't understand it, didn't make any sense. But let's go ahead and get into it, see what we can do. Do the share thing here. Okay. Now, this here is the W mitochondrial DNA, which is the counterpart to the X2 DNA in America. And of course, you can see it's taking basically the same route. And if we go back in time, we'll go way back in time. 11,000 years ago, you have W in the America, the United States or America, very early on. And now, the strange thing when I was looking at this, and I was actually looking at another haplogroup, this is the W mitochondrial DNA. You can see the little daughters there, right? Little daughters. And these are supposed to be samples. You click on it, it's supposed to be a sample, right? So these are samples, apparently, that they found. And the first thing that struck me was like, oh, they must have found a burial ground or something. This is 11,000 years ago, right? Must have found a burial ground or something. And I was a little bit shocked when I zoomed in because it wasn't just one daughter. It was multiple, multiple daughters. And so, but it all in the same place, right? So how could this be? How could you have more samples in one place, right? So the curious thing is that it's not just this haplogroup, because I was looking at another haplogroup and it was the same thing. And I was looking for haplogroups that are not commonly seen or known in America, which is the reason why I was doing it. This is 11,000 years ago, and you have these samples 11,000 years ago. Of course, they could be lineages that people have today, samples of lineages that people have today that go all the way back in time. That's what I'm guessing. But you would think that between 11,000 years ago, there would be enough mutations so that it would be a different haplogroup or a different marker, different genetic marker, right? So I zoom into here and you see there's 4 samples here, but the problem is you go ahead in time. What is this? This is 4,000 years ago. And you go ahead in time, you have all these samples, and this is very, very strange, I mean, to me. And where's the one? I actually looked up the R1B, and it took a long time to load, but I was able to get a picture of it so you can see it. This is the R1B in the exact same location. Well, so I'm trying to figure out. It took forever to load this thing because I guess it was slow or something. But anyways, it's more than just one happened. We'll go back to the X, which is also not supposed to. Well, they admit the X is in America now, the X2A. So we go the X. We'll go to X2. We'll just go to X2 and see what we got here. X2. Actually, we should go X dash 2A and see what happens. Because, and of course, this is going to be the same location for all of these haplogroups. I was thinking, wow, this is some burial ground with all these samples in this one place. But I think what they're trying to do, they're trying to get all this information together and either hide it or just make it more practical for people to study it or something, just have it all in one place. So this is the X2 now, and we can see it's the same sort of thing, right? This is the mitochondrial DNA. Now we can go X2 dash A. We'll go to X2 dash A and see if it changes any. I'm thinking it might change some, but I was just curious. I wanted to see what the difference was because the X2 dash A includes the migrations from Europe and not just necessarily the X2A, which is only in America. It's only a representation of what's in America, the lineages that are in America. So let me see if there's any difference here, if it'll come up and show up. Let me see what's going on. Have we got anybody around? Nobody around yet. Okay. So, yep, we're still sharing. Okay, that's good. And we'll see. We got the X2A now. And I don't know if it's basically the same. I guess different, basically the same, whatever. I guess it's not exactly the same, but this would be a representation of what came over into Europe. Okay, slide to the left, exclude younger subclades. So we'll go ahead and slide it. We're back 3,000, 4,000 years. And I don't know if the other one would be any different. But anyways, we'll just move on and see what's going on. And these ages, of course, are not correct. And I would just basically cut them in half to get the actual age. So this 4,400 years would actually be 2,200 years. That would be a more correct date for that. But it was like anything else, everything else that I looked at or looked up, we'll go to the Y chromosome and see what happens. But it was actually interesting because I was wondering about some of the other haplogroups that weren't even. I guess I have to go back to the mitochondrial DNA, but even some of the Asian haplogroups that are not even well known, they showed up in the same area. So let me see. Where am I going to go? We're going to go to C. Well, the C doesn't show up in America, at least not very much, not as much as it's actually there. So, well, let's just go with the let's just go with J2. Let's say J2. Let's just suppose J2, right? J2, of course, is Judaic, so we'll just go there and see what's going on with that. Just just for the sake of looking around and seeing what's going on. Because I saw this place in the middle of the United States, and it just first I thought it was a burial ground, but then I kept finding more haplogroups and more haplogroups, like hundreds or maybe even thousands of samples in the exact same place. That just doesn't make sense. So I think what they're trying to do is to get, instead of putting them all to different locations, which would be all cluttered up. Well, so what if it's cluttered up? But they just kind of like put them all together in one place in the center of the United States. So here's the J2. If it'll go, there. Okay, so we'll go ahead and put the people in. Put the peoples in. The sons. And we'll go ahead and do the same thing. We'll follow it up. If we got time. As soon as it fills out, we can zoom in and see what's going on. And of course, this is modern. This includes modern travel, so we have to go back in time. And so these older lineages are basically too old for anybody to have today. They might have something similar, but not exactly the same. As a matter of fact, they'd probably be a different letter anyways. But this is, I guess, quite a bit of information somehow. And it's taken a while to load, of course. And maybe I should have tried another lineage, but right now, I'll have to wait for it to show up. Sometimes takes a while. Let me see. Let me go ahead and see what's going on here. Oh, I got that problem. It's not working so well for me right now. But anyways, it should work pretty soon. Actually, when it gets like this, I got to restart the whole thing. I got to restart the computer. But I'll wait this out maybe. See what happens here. Sometimes it kicks me off the thing. I should have checked that before I started, but should have restarted before I started the stream. I just want to get this out. It was working out pretty good. That's probably why, because it can't work good forever. So much for that. Let's see what's going on. Nothing, not a whole lot here. Let's see what we got here. Now I'm just stuck waiting. But anyways, yeah, the haplogroups in America, the first two that I just showed were mitochondrial DNA that was conspicuously or suspiciously in a location where at least the W, there's a W and then there's an I too. There's actually an I besides the W that we just saw. And the X is known to be there, but the W and the I are not very well known as to being in America, and they clearly cross over very early on. And the other thing to note is the direction of the travel, because the lineages go from the more original lineage to the later lineages, so you can see the direction of travel. You can actually see the direction of travel. Yeah, this computer is just not working right now. But as soon as it straightens up a little bit, I'll be able to zoom in. which might not be very soon, because this is taking way too long. But anyways, the thing is, maybe I'll have to do it again some other time. But it shows the exact same thing with all kinds of haplogroups that you wouldn't even know were in America, like and the X and stuff. Let me see what we got. I got anything here? Oh no, it's not even working yet. Yeah, yeah. This computer is yeah. Even some haplogroups such as the C's, Z, the C we know about, but the Z and the G and the E, some of these, the M, these are Asian mitochondrial DNA. And of course, the Semitic mitochondrial DNA are many, many more. So Japheth had 7 sons, but he didn't have as many daughters, apparently. Shem only had 5 sons, but apparently he had more daughters, enough for Madai to ask to marry one of his daughters, which is the A haplogroup. Where's the A? The A haplogroup in America, which is this purple like thing here, color. So it's the A in America, which is known to be in America, but I used to think it followed Madai through the Bering Strait, but now I realize that the Medes crossed off through the Mediterranean, off the coast of Africa, straight to Central America, and spread out from there, as in the previous video shows. Okay, so I think maybe this thing's cooperating now a little bit. So I'll try to move it. Okay, try to zoom in a little bit. Okay, hold on, take it easy. Zoom in a little bit. Yeah, this is really not working out. But I just wanted to show, and this is not just a few of these haplogroups. It's both Y chromosome and the mitochondrial, both Semitic, both Eurasian, and even African mitochondrial, and I didn't even check all and even some of the Y chromosomes. They all converge in the same place. I was just wondering, maybe somebody can help me try to figure out exactly what the meaning of it is. But apparently, they're just trying to keep it organized and not too cluttered. And because of all the samples that they actually have, they have a lot of samples, but I don't think all the samples are being found in one place. I'm pretty sure that these samples are from multiple places being combined into one place. So yeah, you can see where it's starting to separate instead of one sample. It is starting to show many samples. If I can get it in the middle. Okay, try to zoom in a little more, and I think you get the idea, because I could show many, many more examples of this, and probably in Europe it's the same thing as well. Probably it's the same kind of thing, but I just thought it was strange because I was looking at haplogroups that are not known to be in America, and they were showing up here in high numbers. For example, the J2. Well, a lot of people don't know that the J2 is in America in the American native population. So we'll just go ahead and see if we can zoom in some more. And the same thing goes for the I1 and the I2 and the J1. And the interesting thing is when you go back in time, it's all showing up in the exact same place. So obviously, this is not one burial site because it covers a large amount of history, right? Or a large range of dates, of ages. But this this computer is not working, so I'm just gonna have to end it here pretty soon because it's not cooperating right now. I'm gonna have to restart the thing and get it going. But anyways, that's about it. I think you can get the idea. Is that either they're hiding stuff or they're just organizing stuff, or but the thing is, it's a lot of haplogroups going way back in time that are not necessarily known to be in America. That's basically the point I was trying to make. So, and this is J2, but it of course includes recent history. If this thing doesn't want to go back in time, it doesn't want to slide back in time. But there are some lineages that go way, way back in time. Now, are they trying to obscure that or what? This is 35,000 years right now. I mean, 3,500 years, now it's 1,400, 14,000, 12,000, 10,000, 9,000, 8,000, 7,000, 6,000, 5. There we go, 6,000, 5,000, 5,300 years. And you cut that in half, that's uh, almost 3,000. No, yeah, 3,000 years. If you cut it in half, so it's going way back in time. And I don't think anybody living today has a lineage that far back in time without any changes, right? So that's just the general idea. And it's not just one haplogroup, it's many, many haplogroups converging right in the exact same area. And there's, you know, it's just a little bit hard to say what the purpose of this is for, or what they're trying to do. I hope they're not trying to hide the evidence or hide the information because not everybody's going to zoom in. But anyways, that's about it for right now. I think it's good enough for right now. So everybody, hope everybody takes care. Have a very nice rest of the day or week, and take care because truth is better than fiction. Truth is more interesting than fiction and made up stories and made up ages. The actual truth is so much better. The actual truth is just what we need to follow, what we need to go by, right? We can't be going by these made up stories that people, they don't have any actual scientific evidence to back up what they are saying and what they're believing as far as deep time and stuff like that. Because we have a known history going back 5,000 years. Calendars go back 5,000 years. Genealogies go back 5,000 years. They all go back. Everybody's genealogy goes back to 16 ancient civilizations that are known by name, and the Bible names them by name of their original ancestor before they became civilizations. Elam, Elamites, Cush, Cushites, Asher, Assyrians, on and on and on and on. Madai, Medes, everything. Put Phoenicians, at least the original North African Phoenicians. just on and on and on. We have this known human history, and now we have the evidence to back it up. We got the evidence to show that the Medes came when they went up against Lydia. At that time, when they came up against Lydia, they, according to their dating method, they were already in Central America and spreading out from there with a Q haplogroup, which is the male lineage, with the A haplogroup, which is the Semitic lineage that Madai asked to marry, which is the one of the daughters of Shem. So the daughters of Shem are with the Medes. Then there's the the Asian mitochondrial DNA from Eurasia, from Japheth, the daughters of Japheth, the C and the D, and they both, or they all four, converge in Central America and spread out from there. And this is news to me because nobody ever came up with this information. I mean, came out with this information. Obviously, somebody has the information and never came out with it. But now you know. Now you know the rest of the story. Now we know the truth. And the truth is what we need to go by. We can't follow stories like the Bible says. We can't follow made up stories and invented stories. We have to go by what the evidence is. And the evidence is of a history from 5,000 years ago, which is the descendants of Noah, the 16 grandsons of Noah, which became the 16 ancient civilizations, which became all the haplogroups that we have today, and we can follow them all around wherever they went, like we've been doing. So God bless everybody.